Alright, in this problem it tells me to simplify secant of theta over sine of theta times 1 minus cosine squared theta. Okay? Now, I don't see any obvious things to do, so the first thing I'm going to do is I'm just going to separate them into fractions. Secant of theta over 1, 1 over sine theta, and then I have this parentheses, 1 minus cosine squared theta, which I'll just leave it as it is. Secant of theta is what, class? 1 over cosine of theta by the reciprocal identity. 1 over sine, I'm going to keep it. So if I got stuck, I'm just going to change all of them to sine and cosine. Okay. Now look at this one here. This one looks like a variation of the Pythagorean identity. Which Pythagorean identity does it look like? Sine squared plus sine squared equals 1. Yes? Huh. I need to get 1 in cosine by itself. Sine squared equals 1 minus cosine squared. Raise your hand if you did that. Okay, so there, that's what I need. There's 1 minus cosine squared theta. So instead of writing that, I'm going to write what? Sine squared theta. Now I can look ahead and think about this. I have fractions. Pay attention. And I also have sine theta squared. Is that the same thing as sine squared theta? Yeah, that just means you have 2 of those. Does that make sense? So I'm going to cancel off 1 sine. Are you guys watching what I'm doing? Right? Because that's sine times sine. And in the numerator, I just have 1 sine over cosine. And class, what did we say about fractions? Try not to have fractions. You guys remember that? So sine over cosine is tangent. By the, which identity? Quotient. So here to here, that was my Pythagorean identity. And my answer is tangent of theta. Raise your hand if you got that. So as you're doing this problem, think about a couple of things. Number 1, is there any obvious substitutions of identities I have? Sometimes you will see it obviously right away. If you get stuck, change them into what? Sine and cosines. And then remember, in this case, this might be the first time you've seen this, a variation of the Pythagorean identity. Okay?